So as far as a sketch of a graph goes, this is a parabola opening down, shifted up 2, and so it, oh boy, I got to try to graph a parabola. We're just going to go with, that's all right. Going with that one. Okay, so it's frozen, so you didn't even get to see my wonderful drawing. Okay, so that is region A right there. It's bounded by that parabola and the x-axis. It says, find the volume of the solid formed by revolving region A about the x-axis. So this is a little bit of foreshadowing, but if you think about this and you visualize what would happen if you did do this, wouldn't the resulting solid like truly be a solid? There would be no holes, no concavities in it. Wouldn't it sort of look like a football, kind of, sort of? And so because there are no holes in the resulting solid, there are no concavities or anything like that, we would use the disk method. And so with the disk method, perhaps you set it up. I like to kind of structure it right off the bat like this and say volume equals pi times integral of r squared. And then we haven't decided whether it's going to be dx or dy, but I like to set it up like that, similar to how I'll set up the washer method later on. So let's decide on the whole dy or dx. You guys remember, what's the relationship between the representative element and the axis of rotation? The relationship. So vertical is not really a relationship. Like if you think about the axis of rotation being the x-axis, and then a representative rectangle or a representative disk, what's the relationship between them? Dx. That's not really a relationship either. The axis of rotation being the x-axis and the representative rectangle or the representative disk have a they relate to each other in some way. How are they related? Horizontal is not really a relationship. That's a description of a line, but you're starting to get closer to the truth. Both of those are aspects of this, but that's base and height. That's not really a relationship. We can say again? No, it's not really a relationship. Maybe Liz knows. The horizontal axis of rotation, being the x-axis, and the representative rectangle that's going to get rotated around and create all these disks, they have a relationship. They're perpendicular. There we go. Perpendicular is a relationship. Beautiful. Well done. So we get these tall, skinny representative rectangles, and we could fill the whole figure with those, but I'll just do a couple of them like that. And this does lead us to a dx. Let's talk about why that is. We would always think of the width of the rectangle as being dy or dx. That's how we determine this. And the width is measured on the x-axis. And so this would be a dx representative disk or a dx representative rectangle. That, of course, is super important because that means that everything else has to be an x. So that little dx that we sometimes think of as being this, it's just sort of like some punctuation that we don't really have to pay attention to. That's what determines our entire course. Everything has to be some kind of an x. Does that make sense? So maybe the next thing we could do here is we could plug in the limits of integration. So if I've got these vertical representative elements, I'm going to accumulate from the left side of the region over to the right side. So where would I start accumulating these? At x equals negative root 2. That's right. So right here, that point is negative root 2 comma 0. So I'd start accumulating at negative root 2. And over here, this point is? Positive root 2. I'll obviously have some lovely symmetry there. And I get this. And of course, what goes inside as the integrand is r squared. And so r, you could just think of it simply as radius, right? It's the distance from the axis of rotation out to the outer surface of the region, or outer surface of the solid, I guess you could also say. So in other words, how far is it from this blue dot to this blue dot? How would we describe that distance? Say again? 6. I'm guessing no. So you could think of it a couple different ways. Like somebody could put y right there, because literally that's a y distance, isn't it? From the x-axis up to somewhere, that's a y distance. And of course, y equals f of x. This is getting a little bit closer to what we want because we want this to be in terms of x. And so what is f of x equal to? 2 minus x squared. That is the y value, and the y value is what describes the radius or the distance from the axis of rotation for this one. So we plug in there. So that's a lovely setup right there. I asked you guys to try to do this without a calculator, and it was interesting. Some of you like really balked at the whole, do I have to FOIL this? And my response was, well, be thankful it's not to the 10th power, right? Because that would be way more time consuming. So let's try this really quick, and I will have, and I don't know, nobody said anything about it, but I also did not look at every single person's paper in here. There would be a slightly easier alternative to what I'm about to do. So let's see here. So integral from negative root 2 to positive root 2. And if we FOIL it, it's 4 minus 4x squared plus x to the 4th. And then we go term by term and we do our antiderivative. So it'd be pi times 4x minus 4/3 x cubed plus 1/5 x to the 5th. Evaluated from negative root 2 to positive root 2. And then we plug in, right? So it'd be volume equals pi times, it'd be 4 root 2 minus 4/3 root 2 quantity cubed plus 1/5, blah, 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 all to the 5th, minus, and it's the same sort of thing over here. It'd be negative 4 root 2, oops, that's supposed to be a root 2, and let's see, it ended up being plus 4/3 root 2 cubed. And then it'd be minus 1/5 root 2 to the 5th. I think I did all that right. Make sense? I kind of like multiplied out the minuses and got those the places I wanted them. So some things that might add out, right? See here, volume equals pi. Let's see here. It would be 8 root 2, wouldn't it? Okay. And then I guess it would be minus 8/3 root 2 quantity cubed there. And then it would be plus 2/5 root 2 to the 5th. Right? Yeah. Got some nice, lovely like terms to be added there. I don't know. Do I have to keep going? That's a good question. Maybe I do, maybe I don't. As you know, on an FRQ, I could have actually stopped right there, right? But this would be a little cleaner. Anyways, anybody take it further than that? Yeah. So let's see here. So it'd be 8 root 2 minus 16/3 root 2 plus 8/5 root 2. So they're all like terms, common denominator of 15. So it'd be what, 120 minus 80, so it'd be 40 plus 24. Do you guys get 64/3 root 2? Or 15ths. Duh.
And you need pi first.
Oh yeah, we got to have the pi in there. So times pi times pi. So 64/15 root 2 times pi. A lot going on. Did you guys? I mean, maybe you made a little error. Maybe you forgot the pi, whatever. But did you more or less follow this strategy? Yeah. Anybody do anything different as far as like your general strategy? Anything? Okay, well, let me present one alternative. I won't take this all the way through just for time considerations. But check this out. What if somebody noticed something that we didn't talk about and decided maybe this would make it just a little bit easier? So instead of that original setup, what if they did this? What if they noticed that there is, as mentioned earlier, there is a lovely symmetry? In other words, the y-axis is a nice line of symmetry. In other words, the left half and the right half are exactly the same. Here's what someone could have done, and I think there would be merit for this. They could have said volume equals integral from 0 to root 2 of 2 minus x squared dx. The pi would need to be there, but what else would need to be there? Times 2. So, whoops, there we go. So this should give you the exact same answer, right? Because of the symmetry involved in this shape, this solid. Why would someone choose to do something like that? Why would it make it easier? The 0, right? It's 1 less root 2 you got to keep track of, right? 0 is nice. Tends to make things a little bit easier when we're talking about polynomials and this square roots and that kind of thing. So that would have for sure been an option for you. Any questions at all on the disk method? No. Okay, so next time we're going to look at the washer method. So make sure that you do what you got to do with that video or whatever. So let's have Jasmine and